Good morning or good afternoon. Hope you enjoyed your 3-day weekend. I don't know if I enjoyed mine yet or not because it's still Thursday night when I'm making this video. So hopefully I enjoyed mine too. All right, so today we're starting a new topic. We're going to be talking about this at least for this week, maybe a little bit longer, depending on how many of you are stuck in I-step testing this week. So we might have to extend it into next week a little bit to make up some time. But the topic is standard deviation. Pretty important topic in the field of statistics. We have a large unit in statistics coming up at the second semester. We spend quite a bit of time on it, and this is one of our main focuses. But today we're going to get the basics. So standard deviation is a number that relates to how much variation there is in a set of values. Essentially similar to the range, but with a lot more detail. So for example, if there's a large range, like your range is 100, that means you have numbers that go all the way from 0 to 100. They go the whole span. That's a pretty big zone of numbers. But if the range was 10, the numbers only went from 0 to 10, it tells you that the numbers are more clumped together as opposed to being spread out. So the standard deviation kind of relates to how far the numbers are spread out. All right, now there's a new symbol for it, and I can show it to you right here. It looks a little bit like a 9 tipped itself over, like there was a 9 standing here, and somebody came in and chopped a little bit of his legs off and then kind of just knocked him over onto his side. It's kind of what he looks like. All right, so it's the Greek letter sigma, lowercase sigma. So if you know anything about Greek lettering, that's what that one is. And if that number is small, it means most of our values are close to the median. So we have to find the median here. So again, that's a key number in doing standard deviation is the median. And if again, I have a small standard deviation number like 2 or 3, it tells us again my numbers are all clumped near the median. If I have a large standard deviation, that means the values have a large range and that they're all spread out all over the place. Now, standard deviation again tells us a little bit more than just the range does. And the way it's going to work is it's going to play a part in what's called the normal distribution curve, sometimes referred to as a bell curve. Now, normal means that, again, all the information is kind of equally spread out, with the largest clump of information being right here in the middle at the median. Again, remember median where we list all the numbers in order and then we talk about which one's in the center. So this is visually also in the center. Splits the graph exactly in half, and the left side and the right side of the graph look the same, like a mirror image, a little bit like a parabola, but not quite exactly the same. So that's a key number. We want to find the median. We put that median right here in the center. Now, to the right, we add standard deviations. All right, so let's just say random, for example, that the median is 50 and that the standard deviation is 5. That means to the right, I'll be counting by 5s, and I'll count out 3 spaces. All right. Anything more than 3 standard deviations away from the median is officially considered an outlier. And then we do the same thing to the left. We subtract standard deviations from the median. So if the standard deviation is 5, I'm subtracting 5 as I go to the left. And I go 3 spaces exactly, no more, no less. Anything that would be in this particular problem lower than 35 would be considered an outlier, not expected, or very rare. All right? Things closer to the median, you would expect to get lots of them. That's why there's more space here in this middle section than there is out here on these edge sections. We're going to talk a little bit about that tomorrow. All right? But today we want to learn about how to set up the graph. So here's an example. All right? We've got a graph where the median is 45. So again, I'm looking for that one that's in the middle. There it is, right there. That's 45. All right, and then my standard deviation is 6. That means as I go to the right, I'll be counting by 6. So 45 plus 6 is 51. 51 plus 6 is 57. 57 plus 6 is 63. And that's it, no farther. Now to the left, I'll be subtracting the standard deviation. 45 minus 6 is 39. 39 minus 6 would be 33. 33 minus 6 would be 27. So again, that means in this particular problem, 45 is the median. Most of the results and most of the answers are landing near the median. That's why, again, if we were doing dot plots, you would see much taller dots near the middle here, and much shorter towers of dots out here on the ends. All right, so it's kind of like we took a dot plot and just drew a line across the top of them. And again, what we see is the farther away from the median you get, the fewer dots you have at each particular number. Out to the end here, where it's pretty small. Right, but in the middle, on the left and right side, you get these larger towers, because again, you're having more answers in that area than you are out here, where your little towers will be shorter. Right? Hopefully that makes sense. Okay, we're going to be working with this one for a lot this year. This is a pretty important topic for anything statistics related, is the idea of standard deviation and then this normal distribution curve. All right, your work will look similar to this today. It shouldn't be too hard, but if you need something, let me know. Have a good luck today. Have a good luck today. Did I really just say have a good luck today? Yeah, have a good luck today. I hope you enjoy it. Maybe it tastes good. So enjoy. Bye.